Good evening, everyone. This is Atmospheric Alex here, and in today's video, we're going to be talking about the upcoming severe weather chances for the northern and high plains areas, as well as some space weather activity as well towards the end of the video. And we're going to start today off by taking a look at the Storm Prediction Center's convective outlook, where we do have a slight risk of severe weather here for portions of northern Nebraska, eastern South Dakota, and portions of southeastern North Dakota, portions of Minnesota there as well. As we take a look at what our main hazards could be today, we're talking about a tornado risk, potentially even a chance for a strong tornado in there as well. You have a bit of a wind risk as well, nothing too crazy there, and a very large hail concern across some areas. We could be talking about some pretty intense supercells today across some of those areas. As we take a good look at tomorrow's outlook here, you can see again we do have that slight risk for severe weather for portions of South Dakota and Nebraska again, and that large marginal risk accompanying a lot of other areas. As we go ahead and take a look at our main hazards, we could have the chance for a tornado. I personally do think the chances is a little bit higher than this, say across the Rapid City, South Dakota area, where it does look like a mesoscale feature could set up and could promote potentially, maybe, and don't count me on this, maybe a strong tornado risk. As we head into our wind risk, again, generally a 15% risk there, and a very large hail risk off to the west a little bit. Onto our day 3 outlook, once again, we have another slight risk. So, like I said, and like the title stated, things are starting to pick up in activity again. We went through some pretty quiet times in terms of little to no severe weather, but we are back in a more favorable pattern here. Again, Nebraska, Iowa there, portions of Minnesota and Wisconsin, that is what that looks like. As we head into day 4, things shift a lot further off to the northwest, across portions of North Dakota, Montana, and even Canada there sneaking on in. Now, of course, that risk goes further to the north, but we do have that slight risk in place. Now, as we go ahead and take a look at our current radar here, I am using Weatherfront here for today's video because I saw that they released a ton of new graphics on their website. This used to be a mobile app, but now they've expanded to a desktop, which is really cool. But you can see we do have some severe weather popping up across portions of South Dakota, even North Dakota there a little bit. We have a pretty good supercell all the way down here as well. When we turn on our radars down near Pierre, South Dakota, look at all that lightning activity as well. We are seeing a lot of it. We're seeing also a lot of storm spotters going right up into the storm right here. So definitely getting a pretty good look on that. But I do believe that storm might have a little bit of rotation in it as well. As we take a look at our velocity tool, you can see coming into view a nice couplet right there. Let me pause the frame. We have nice red colors here and green colors here. Again, oh, look at that. We just got a tornado warning for that supercell. I just kind of called it out there. So there was a couple of rotation, and so the National Weather Service did issue a tornado warning here for portions of Hamill, South Dakota. As we zoom in, Ideal, South Dakota, getting near Winter, South Dakota as well. We're probably seeing a bit of a wall cloud right now. We have some rotation being observed, and look at that. Just got a tornado. So wow, what timing was that? Intermittent condensation funnels. Yeah, this is a really cool website, and I will be using this a lot more in the future. So yeah, please, take cover, get underground, get into the lowest airmost part of your building if you live in the tornado warned area. Now we're going to go ahead and take a look at what the future radar could look like according to the HRRR model. Again, you see supercells popping up across South Dakota here. Look at all that right there. And one of those is producing a tornado. That one down near Winter. That's not really depicted well in the model, but you can see lots of severe weather there. As we continue through time here, as we head into midnight and even past that, got a pretty good line of storms, a bit of a bow echo pushing through Watertown, Brookings, South Dakota there, and then that continues on throughout the night. As we take a good look at our parameters here, we do have some pretty high dew points across the board here into the 60s. That will continue on through. You can see our 60s kind of remaining into our overnight hours as well. We're going to go ahead and take a look at our storm energy now as well. We do have a lot of it present here where our tornado warned storm currently is, around 3,000 to 4,000 CAPE, as well over enough for severe weather and certainly supportive of intense supercell development. Our CAPE will continue to wind down a bit going into the overnight hours. Now this is pretty cool. This is going to be our low level to upper level CAPE here, or 0 to 3 kilometer level, and you can see we have a really nice area here of storm energy favorable for tornadoes. That is exactly why you have that supercell there in your Mission and Winter, South Dakota. So definitely really interesting that you can see this on the model. And let's kind of see, does this continue to move on through? It looks like it does. And really, as we go around midnight tonight is when that pocket of decent storm energy will fade away. That's likely when our supercells will consolidate into a line. It will begin to rapidly weaken. We do have a teeny tiny pocket of helicity right here as well. That is why we're seeing our tornado being a little bit more sustained across that area. And this pocket will continue to move through, but becomes, like I said, a lot more linear in nature. As we go ahead and take a look at tomorrow's severe weather risk with what the radar could look like, there's going to be a lot of supercells here across North and South Dakota, potentially starting tomorrow evening. We have a little bit of thunderstorm activity, maybe some strong to severe weather here across portions of Iowa. I'm seeing just a little bit of a storm complex there, nothing too crazy. As we go through time, these supercells may intensify a little bit more. And yeah, take a look at that one right there. Let's actually zoom in near Aberdeen there. Look at that. Certainly would produce some very large hail there, would be a tornado risk as well, without a doubt. So that turns into a complex of storms. We have another complex of storms behind that. Nasty bow echo, Boeing segment impacting Aberdeen, Redfield, Watertown overnight. That could definitely contain maybe 70 to even 80 mile an hour winds, possibly large hail, and then of course a tornado risk as well. As we kind of do a little bit of a deeper dive on some of our parameters here, I'm still getting used to this website. As you can tell, I'm trying to navigate all over the place. It's a little confusing, but you can see we do have sufficient dew points across the board, again in your mid-60s, even approaching your upper 60s there. Very favorable for severe weather. Our storm energy, we certainly do have enough of it here. Look at here across the Black Hills of South Dakota. We have a little pocket. That could be a little bit more favorable for severe weather. We'll see if we get a supercell right on that bullseye of 4,000 storm energy, but we'll have to wait and see on that. But as we go later on throughout the evening, we have a nice little corridor here setting up of 2,000 to 3,000 storm energy. That is where rapid supercell development is going to be possible, if not even likely. Any tornado hot zones in particular, again, look at here across Rapid City, South Dakota, your Black Hills. We do, in fact, have our surface-based storm energy that could definitely be favorable for perhaps even a tornado. And then, of course, across these areas up here, nice little pocket right there. That is definitely going to add some more favorability. Storm relative helicity goes kind of like this. You see a little pocket back here, but really right up through here, you see some blue colors, some yellow colors on your screen. Heightened tornado potential. I don't expect a strong tornado as of yet, though that could definitely change. We might introduce some higher levels of wind shear. You never know. It's going to be a mesoscale accident type of day. It's a typical June day in South Dakota. And now we're going to go ahead and switch gears real quick, as the sun has been really active lately. We've been seeing a lot of solar flares from active region 4455. We're going to roll the animation on through here of sunspot region 4455. You could see the cluster right there popping off some pretty good flares over the past few days. I mean, look at that pop right there. And then we see, boom, right there. That was a high-end M-class flare. Boom, another one. I believe that was the X-class flare, I do believe. There's a lot of flares to talk about that have came from that sunspot region. And we're going to go over what it looks like in a graph here. So yes, here's our current solar flare graph. And you can see, a lot of these peaks right here. These are all of our solar flares that have occurred on the sun over the past 3 days, really the past 2 days, even a little less than that. You can see as we go throughout time, these get more and more intense. Before you know it, we actually have an X-class flare. That was the most recent one. This actually didn't really capture it too well, but believe me when I say this was a powerful solar flare that happened really early this morning. And we're going to kind of go ahead and visualize this a bit differently here. This is basically a tool we can use to partially block out the sun and reveal all of the particles panels coming off of it, basically. It kind of provides a light shield for the instrument so we can see all the solar storms coming off the sun. You can see all this material being ejected here, and every once in a while you'll get something a little bit bigger right about, let's see, right about here. Did you see it? We're going to rewind that a little bit and kind of take a better look at this. As you can see, we have what looks to be a full halo coronal mass ejection coming off the sun right here. You can see right there, sort of the outline of it there on its outer edge. Kind of all this out here is your full halo, and that means that this solar storm in particular is heading directly towards Earth, which is great news for you all who want northern lights. And then we have another one right there, and another one that may have also been a full halo CME. So there's a lot going on right now heading towards Earth tomorrow night. And so we are able to use a model that looks at this. This is the Enlil model from NOAA here, and it basically shows you all the solar storms coming off the sun. You can see one right there, another one right behind it. You can see this one definitely looks to be pretty strong here. You know, a fairly dense solar storm here and a fairly fast solar storm. You can see our wind right here, solar wind, upwards of 900 kilometers a second. So this one could be a pretty good hit to Earth, it looks like. That is not a forecast. Believe it or not, I know that I'm covering space weather right now. I don't usually say that during space weather briefings, but we do run the risk of this potentially going to the north of Earth, and we're going to kind of have to monitor that closely. But we're going to continue to loop everything here. Look at how strong this thing gets. This model is pretty inaccurate, though. It combines both of our solar storms into one, which is physically impossible. That doesn't happen. So you get this Carrington level event here on the model, which is not going to happen. This is way overdoing the solar storm's intensity here. But still, we're going to see a pretty big hit, it looks like. And look at all your solar wind kind of remaining behind. That is definitely going to be a pretty big blow to Earth. As we look at another model, this is our Hux-T model here. This is basically another tool you can use to see the solar storms coming off the sun, and boom, boom, right there. Those were your two predominant solar storms there. The ones that we saw on our previous model run and on our coronagraph imagery, those two full halo CMEs. That is what we're looking at there. And Hux-T is very aggressive with this output here. You could see showing very high solar speeds, well in excess of 800 kilometers a second, even breaching well over 1,000. I do think this model is going a bit out to lunch, but it does show two pretty big impacts there. With the second one there, and I kind of want to note this, being more of a glancing blow, you can see it where it has its polygon drawn. It is just outside of Earth right here. That black dot, that's Earth. So it just passes right on by. We could get the legs of the CME, and that is definitely something we need to watch out for. But we're talking about prolonged, potentially favorable conditions for northern lights. And here's a more graphical look at it here. It is going to potentially be arriving tomorrow evening. Well, really late tomorrow afternoon, but you're obviously not going to see anything until it gets dark out around 9:30. I hope it doesn't hit too early, my goodness. You can see we do have values going off the charts here, so a very fast solar storm is possible. I think this is really being too aggressive. I think somewhere around 700 to 800 kilometers a second is probably your best bet, but that's still a pretty good impact if you ask me. I mean, for sure, nothing to really scoff at. This could maybe get up to levels of November 2025, if you remember that particular event. That was pretty crazy indeed. And now I do want to express the uncertainty with this upcoming solar storm. We're looking at the NASA model now, and it shows something a little bit different. It shows this solar storm only delivering a glancing blow here. That is very interesting. It shows actually quite a bit of it missing Earth. So that would definitely result in a lower end outcome, but we would still potentially see, G1 level storm impacts. But I do think that this storm upcoming has a very low floor, but a very high ceiling. All right, people are comparing this to May 10th, 2024. I don't think that's going to happen. That's a little bit aggressive at this time, but I do think that November event from, last year, basically, that November 2025 event might be a little bit similar to this one, but we're just going to have to wait and see how things pan out. If we do get a big hit, it's going to be pretty big. If the magnetic field can cooperate, if it can be rotated the right direction, we could be talking about a pretty good show. And a pretty good example of this is a little bit of a graphic I drew up quite a long time ago. This is your BZ right here, basically your orientation of the magnetic field, and you want it all to be pointing south. If it's pointing south, well, the northern lights are going to go further south, and they're going to be more intense in nature. So, as you can see, I put here lots of charging ongoing, allowing for a southward push of northern lights. And you can see right here, we do have our values kind of sticking around -10, especially like right here. We have another good zone right here, and towards the end, it stays pretty far south as well. Let's say this all was north. Well, the January 2026 storm from this year that had, an IMF of around 100 nanotesla was all north. We didn't see much from that event. If that was south, that would have been potentially a generational experience. So we're going to have to wait and see what winds up happening tomorrow night. And then also another key factor to kind of note is substorm activity. Your GOES magnetometer data showing the following. Your red line here is what you're really paying attention to. If you suddenly see things kind of drop off like this, if you see a lot of charging ongoing in your magnetosphere, and then suddenly boom, it goes up like this, that charging being released will cause a substorm and basically an explosion of northern lights. You can see right here, fast bout of charging, boom, pretty good substorm. Very fast and intense bout of charging, and bam, that was a very strong substorm there that occurred. Intense substorm activity may continue, and that pushes northern lights potentially deeper into the mid-latitudes. Could we talk about that tomorrow night? It all depends on what happens in real time. And with that being said, thank you all so much for tuning in to today's video. I really hope you enjoyed it. I do apologize that there were quite a few jump cuts in this video. I think from now on, things will be done on my laptop. This computer is kind of been acting up on me a little bit lately, so hopefully I can find a good fix to that and we can get things back up and operational. That being said, if you enjoyed the video, smash the like button, subscribe to my little corner of the weather community, share this video with friends, family on social media, and even feel free to leave a comment in the section below if you have any future ideas for me next. And with that being said, have a wonderful night, everyone. Stay very weather aware out there and enjoy the northern lights tomorrow night. Remember, to get an accurate photo of the northern lights, you must take a photo of them in night mode on your phone. That is how you get all the colors out and things look really awesome.